Ethereum. And if I go ahead and again give you the anatomy, mind you, can always fall back on the analogy of how a packet looks like. You would consist of application where it is available to you on Linux, on Mac, as well as on your smartphone. Then the decentralized application, or these are the front end. So what would be there in the back end to go ahead and take care of the blockchain? Well, you've got Swarm, Whisper, EVM, the hardware clients, and the internet in conjunction, which form the Ethereum base. And we're going to go ahead and discuss this one by one, each and every layer taken independently. So what is Ethereum? First of all, this when we talk about Mist, it's a user-facing layer of Ethereum platform. It's available in smartphone as well as in desktop. Decentralized application or dApps. These are applications that get executed over the decentralized P2P network and have an open source code. And it can be a simple logic, as simple as adding of two numbers, or it could be something quite complex, as simple as or as difficult as microblogging services. Then you've got middleware. The middleware of Ethereum has a flat hierarchy. You don't have a central authority. Well, that is the inherent background of any blockchain. You don't have a central authority. So what all things are there inside the middleware? Well, you've got Swarm, which is the decentralized storage, which is mainly for static files. You've got Whisper, the walkie-talkie of dApp, which take care of the hashing and make sure that the entire environment of Ethereum kind of works in a dark room environment. And finally, EVM, which is an isolated on-the-fly human-to-machine code translator, pretty much works, and if somebody is from the software background, works on the LIFO model, last in, first out, that is in the sandbox runtime environment. So let's go ahead and talk more about Swarm. The primary objective of Swarm is to allow dApps, that is the decentralized application, to efficiently share the storage and bandwidth resources of the data in order to provide the necessary service to the end user. Well, this is basically the middleware which talks about the efficiency of the storage of bandwidth and resources. They have their own particular base address, which is termed as bus key. The way they go ahead and accomplish this is with the help of chunks. The moment there is a data which comes in, it has been broken into chunk with the maximum size of 4 KB. Then the hashing takes place, which is something which we have already talked about, how the hash actually functions. And there's a unique identifier and an address as good as if somebody has been in the networking industry and have read about TCP suite, you would know that each and every packet has a particular number through which you can easily identify a kind of packet which is being flown across the network. Well, hash actually gives you that kind of advantage too. Then you have a manifest. This is the path specifier of a content retrieval of the hash. If at a point of time during the entire network, you would like to go ahead and verify whether this transaction actually has taken place in the network, the way you would like to go is you would like to run the hash. It's not going to give you the original message. That is something which we've already discussed with the infeasibility of the data, but what it definitely do is it's going to go ahead and give you the respective hash which you have seen, which we discussed in the Merkle tree, and the way it would go ahead and show you the path of hash is as good as analogically. You can even go ahead and look at if you have ever run a TCP route on your laptop, on your desktop, on a network, you would see the hops of those particular TCP route which has taken place, or the packet which has actually hopped on from one router or one network to the other. hash actually goes ahead and give you, your manifest actually goes ahead and give you the same. So Whisper, as we have discussed, it uses multi-distributed hash table with routing privacy, and it is a communication protocol which nullify leakage of any metadata and achieve true darkness. By true darkness, I clearly mean that it is purely it takes care of the entire hashing. It makes sure that nothing is available, and finally it works on the two key concepts, which is your messages and envelopes. Now, with the message also comes this common concept of TTL, or time to live. So each and every message has an expiry, and that is why I keep on repeating this analogical discussion about a network and IP packet, as well as the packets which are there in your Ethereum, or as a matter of fact in a blockchain. It talks about how the messages can do have an expiry date has an expiry I would say, and that would go ahead and ensure that the message integrity remains and a message is not hanging for eternity. Finally, we have the EVM, which is a stack-based interpreter. It has a memory byte array and a key value storage. The EVM stack elements are 32 bytes long. There are ops code. Then there are three types of space to store the data. The stack, which was on, as I shared earlier, the last in first out container, to which the values can be pushed and popped. The memory, which is an infinitely expandable byte array, and finally the key value store. So these are the three places where the data is being stored.